Hello, my amazing Algebra Half students. This is Mrs. A, and I love math. And today we are here to talk about right circular cylinders in lesson 77. And so we're going to talk about the fact that cylinders are circular on the base. So we call the bottom of it the base, and it looks like this. And it looks very much like a paper towel roll. Okay, so a paper towel roll is a cylinder, isn't it? So it is a right circular cylinder, and I have a base which is circular. So for right now, we're going to pretend there's no hole. Okay, so we have a base that is circular. We have a top that is the same as the base, and it is circular. And then we've got this around. So what we're going to talk about first is volume. My paper towels are unrolling. How unruly of my paper towels. So we're going to talk about a right circular cylinder. But you see right circular cylinders everywhere. There's a pill bottle. It's a right circular cylinder, isn't it? Its bottom is a circle and its top is a circle, and it's a right circular cylinder. So basically any figure is called a cylinder if it is the same all the way up. I have another cylinder here, but this one is not a right circular cylinder. This is my name tag. Okay, so my name tag that goes on my desk, it's not quite a triangle. It's some sort of a funny shape here. This is a quadrilateral base. Okay, but it is the same all the way up. If I were to stand it on its base, it's the same on both ends, and it's the same all the way through. We would call that a cylinder because it's a shape that is the same all the way up. Okay, so let's think of some other cylinders. That this is a cylinder, but it is not a circular cylinder. Okay, let's think of another cylinder. I came up with another cylinder. This is a cylinder. This cylinder is a square-based cylinder. Okay, but it is the same shape all the way up. So we could call that a cylinder. But here is what we're really talking about today. This is an example of a right circular cylinder. It's a canister that you would put flour or something in, okay? But it is a right circular cylinder. It has a circular base and a circular lid, and that's a cylinder because it's the same shape all the way up the top. So that's what we're talking about today as a right circular cylinder. All right, so when we say right, that means it stands up at perpendicular to the table that it's sitting on. So it's right, it's not leaning, okay? So here we are with right circular cylinders. So let's learn a little bit about it, and then we're going to play with the paper towels. How's that? All right, so circular cylinders are very strong. Your book is talking about how circular cylinders are used to store things like oil that you need to make sure the container can hold very strongly, and they use a circular cylinder because it is incredibly strong. And this cylinder that we were talking about here has a base of 2 meters. And it's got a height of 20 meters. And we're going to talk about this figure's volume, and then we're going to talk about its surface area. Okay, so volume is how much a right circular cylinder can hold. How much can it contain? Okay, so when we're going to find the volume of a right circular cylinder, it's going to be the area of the base times the height. So basically think of it this way. If we knew the area of the base, which is a circle, and right down here, my circle is down there, but you can't just see it because it's sitting on the circle, okay? But that circular base, which is down there, okay, is a certain area, and then that area is moving up all the way up. And the area of the base times the height gives you the total volume, which is how much this figure can hold. Okay, I like to think of the area kind of like a CD that you would put into a CD player, because it's round and flat, only the area has no height at all. So it's very, 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 very skinny. Okay, but then if you stacked that area all the way up to the top, then you would have what the figure could hold. Okay, so it's kind of like that. But this base has no thickness, it just has area. All right, so it's a concept, but stacking up CDs in a CD holder would be a good way to think of it, okay? So we take the area of the base, and then we multiply it by the height, and we have how much the figure will hold. And that's true for any cylinder shape. Suppose the area of the base was a square base. Then we could take the area of the square base and multiply it by the height, and we would get the volume of the figure. So we'll be doing that when we get to rectangles and things like that. But right now, right circular cylinders. Okay, so the area of the base is a circle, so the area of a circle is pi r squared. And so the volume is area of the base times the height. So for a right circular cylinder, it will be pi r squared times height. So I don't memorize formulas. It's not my thing to memorize formulas. I learn concepts. And because I understand that all cylinders have a volume of area of the base times the height, all I need to know is what is the shape of that base and what is its area. And then all I have to do is multiply that by the height, and I have got the volume. Okay, so now we're going to talk about that. We're going to do that a little bit, and we're also going to talk about the surface area. Okay, so we're going to talk about the same type of figure, the right circular cylinder. The surface area, however, is not the volume. The volume is how much it can hold. The surface area is the area on the outside of the cylinder. So when we're talking about a cylinder, it has a top circle and a bottom circle. And then if we were to unpeel, like put a little can cutter there and unpeel the can, it would turn into a rectangle. And the rectangle's length this way would be the circumference of the circle at the top. And then the height would be the other dimension. And to get the area of the whole rectangle, we would multiply the circumference times the height, the circumference of the whole circle there, times the height, then we would get the area of that rectangle. So when we put the area of the top circle and the bottom circle, which are the same, we put those two together, and then we add in the rectangle area, we have the surface area of the whole figure. So let's go back to my paper towel roll, because this is a nice little illustration. Okay, remember, you got to pretend with me a little bit. There's no hole. Okay, so the area of the bottom, and we're also going to pretend like this little bit weird shaped paper towel is really a circle. Okay, so we've got the base of the paper towel is a circle with no hole, remember? And the other end is also a circle, the same size with no hole. Okay, and then let's suppose that I'm going to unpeel the outer layer here. So just to make it easy for us, I'm going to take my little marker and I'm going to run down the edge of the paper towel. Okay, so I ran down the whole length to leave a mark, and then when I start to unroll the paper towel, right? We unroll paper towels all the time, but this is more interesting. Guess what I have? Don't I have a rectangle? So basically, I've gotten back to the end of the paper towel where I started, and this would be the area of the outer, what we call the lateral surface area of the figure. Okay, so we have the area of the top, we have the area of the bottom, and the area of the unpeeled side, which becomes a rectangle. We call this the lateral surface area. We put them all together and we get the total surface area of the figure. Okay, so I'm going to tear off this rectangle. Okay, and it didn't quite tear on the right fold, so I'm going to fold it down a little bit. There. So we've got where the little line was. This is the area that wraps around my paper towel roll. Okay, so what I would have to do is I would have to get this right here all across the top. Wasn't this what wrapped around the paper towel roll? Okay, so what do we call something that wraps around? Isn't that the circumference of the circle that was on the top? Okay, so this top part of the rectangle here, with this part folded under, the top part of the rectangle is the circumference. And then this was the height of the paper towel roll. Pretty cool, huh? All right, so let's look at our little figure here. So I've drawn you the right circular cylinder. Okay, so in the problem we're going to do, we're going to say that the radius of the circle that's on the bottom is 2 meters, because we're sticking with the original problem in the book. And the height was 20 meters. And we're going to find the surface area of this figure. Okay, so the area of the top is pi r squared because it's a circle. And the area of the bottom is pi r squared because it's the same circle. Okay, and then the circumference is this distance around, and that's 2 pi r. Circumference is 2 pi r. And there's the height. Okay, so when I'm going to find the total surface area, it's the area of the circle plus the area of the same size circle. So I could just double it, couldn't I? And then it's going to be the circumference times the height gives us that rectangle we were looking for, as if we were to cut right down here and peel it off. And here we go. So the area of the top circle is pi r squared. Since the r is 2, that's going to be pi 2 squared. And then we're going to do it again because we have the circle on the top and the bottom, so there's another pi 2 squared. And then my circumference is 2 pi r, so that's going to be 2 pi times 2. And then the height is 20. So when I put all that together, that's going to be a 4 pi plus another 4 pi. Plus, when I multiply all of this, a 20 times a 2 times a 2 times a pi is 80 pi. So 80 pi plus 4 pi plus another 4 pi is 88 pi. So my total surface area of this figure was 88 pi. Okay, so don't go away. We're going to do a couple more of these. So now I've changed the problem a little bit. We're going to find the volume of a figure. Now this one, I kept the height of 20, but now I have a radius of 3 instead of 2. Okay, so we're going to find the volume and the surface area of this figure. So first we're going to do volume, and volume is area of the base times the height. Okay, the base is a circle, so the area of the base is pi r squared, because that's the area of a circle, times the h. Okay, so now I'm just going to fill in with what's on my figure. Pi r is 3 this time, so 3 squared, because it's an r squared, times the height, then the height is 20. We're assuming these all have the same units, so we'll make them all meters, okay? So then we have 3 squared, which is 9, times pi, times 20. So I'm going to take the 9 and the 20 and multiply them together, which is going to give me 180. So I get 180 pi is going to be the volume. Now, one thing we didn't note here, volume is in cubic units. All right, so let's see why that's going to be so. The area is always in square units, and then the height adds another dimension. So if you think about it, this radius, we said it was in meters, so the radius is 3 meters. But then for the area, we square the 3 meters. So we're really getting 9 meters squared. And then the height is also in meters. So we get 9 meters squared times 20 meters. So we have meters squared times meters is meters cubed. Volume has cubic units, like meters cubed. Area has square units, like meters squared. All right, so now we're going to do the same figure, but this time we're doing surface area, the total surface area. So let's see if we can remember how to find the surface area. We take the area of the top circle and add it to the area of the bottom circle, which is very easy because they're the same size circle. And then we unpeel the rectangle all out, just like I did my paper towel roll, and we're going to get a rectangle. And that rectangle, remember, since this rectangle goes all the way around the top circle and the bottom circle, it's going to be the circumference of the base times the height of the whole figure. So circumference times height gives me this rectangle. So circle, circle, rectangle. We find all the areas of those 3 things, we add them together, and we get our total surface area of the figure. Because our figure here, I get my little can again because it's easier to handle. The figure consists of a lid, a base, and that, ooh, this one even has a line here. That's a little rib in the metal. But we unroll the whole rectangle that's going all the way around this thing, and we have a rectangle and 2 circles. And that gives us the total surface area. So here we go. On this one, the area of the base, since it's a circle, will be pi r squared. But then we have the bottom base, which is also going to be pi r squared. So what if we just said 2 pi r squared? What if we just doubled it? We could do that, couldn't we? It's going to be the same thing as adding it to itself twice. And then we have this one. Now remember, circumference of a circle, this distance around, is 2 pi r. So 2 pi r times h. So we're going to add plus 2 pi r times h. Now that's the formula for surface area of a right circular cylinder, but I don't ever think about the formula. I just know how to get the formula. So you can memorize the formula, or you can just know how to get it. Then you don't have to memorize the formula. Okay, so now let's plug everything in. We have the r is 3. So r squared is 9. 9 times 2 is 18 times pi is 18 pi. Okay, so 18 pi is the area of both of the circles put together. Okay, because each one is 9 pi. This one's 9 pi and this one's 9 pi, so I add them together and get 18 pi. That's this part. So now we look at this part, and that's in here, so we can just write it right in here. So now we've got a 2 times a pi times an r, which is 3, times an h. Remember, our h is 20. Our height of the whole figure is 20. So now we have a 20 times a 3 is a 60, and then 60 times a 2 is 120, and 120 pi. So 120 pi is the area of the rectangle. So to find the total area of the whole figure, the total surface area, it's 120 pi plus 18 pi, which would be 138 pi. 138 pi is the surface area of the whole figure. So now we're going to do some practice problems. All right, so we have an A and a B that apply to the same figure. Your book says find the volume of a right circular cylinder that has a height of 30 feet and whose base has a radius of 10 feet. So height of 30 feet, this is all in feet now, and a base of 10 feet. And we're going to find the volume and then the surface area of the same figure. So remember, volume is area of the base times the height. And that applies to any cylinder, any figure that's the same all the way up. But we're going to only worry about a right circular cylinder because that's what we have. The area of the base is a circle. So we're going to have pi r squared, because that's the area of a circle, times the height, which is 30. Okay, so we're just going to put height. There's our formula for the volume of a right circular cylinder. Now let's start plugging things in. Pi r is 10 squared, okay, and then the height is 30. Now remember, this is 10 feet, so that's feet times feet. And then there's a 30 feet. So it's feet times feet times feet. So our volume is in feet cubed. I just didn't carry all of those units on there. So now let's multiply all this out. So we have 10 squared is 100. And 100 times 3 would be 300. But then it's 30. 100 times 30 would be 3,000 pi. So the answer for the volume is 3,000 pi feet cubed. Okay, now that's the exact answer, but if you wanted to get an approximate answer, you could take 3.14 and substitute it in for the pi and multiply 3.14 times 3,000, and that would be a good approximation. But the exact answer always keeps the pi. Depending on what your teacher wants you to do, your teacher might, this would be smart, teach you how to do it the exact way and then tell you to put the pi in there to approximate a more useful answer. Now we're going to do surface area of the same figure and then we'll be done. Okay, surface area of the same figure, remember, is the area of the bottom circle plus the area of the top circle. So we're going to have pi r squared plus pi r squared with the same circle. So that's going to wind up being the 2 pi r squared. And then lastly, the area of the rectangle, which is the circumference, the distance around the circle, and then circumference times height. So that's how we get the formula, circumference times height. So now let's make this a little cleaner. So we're going to say instead of pi r squared plus pi r squared, we'll say 2 pi r squared. And instead of circumference, we'll say 2 pi r because that is circumference times height. Okay, so here's our formula. So now we're going to start plugging everything in. So r is 10, and 10 squared would be 100. And 100 times 2 would be 200, and then the pi. So 200 pi is this whole thing right here, plus, now over here, we plug in the r, which is 10, and the height, which is 30. So 30 times 10 is 300, and 300 times 2 is 600, and 600 pi will be this part of the answer. So if we have a 200 pi plus a 600 pi, then won't the total surface area be 800 pi? Very nice. And that is your practice problem, both of them on one board. And hopefully you have learned a lot about volume and surface area of a right circular cylinder. And this is Mrs. A, and may God bless your day.